All right, so we will start right away, guys. So, good evening, everyone, and a warm welcome to this day 9 of 21 days session. So, as usual, I just want to see like how excited are you guys about this particular training program, especially the session for today. Okay, thank you very much, Shahid. Thank you, Karan. Thank you, Varsha. Okay, thank you very much, Naveen. Thank you very much, Dattappa. Thanks. Good evening. Good evening. Okay, so let's begin right away. I expect you guys to be very high on energy. See, I have told you on day one itself, my energy level depends on the energy level of you guys. As you understand, these sessions are free. I'm doing it for free for you guys. I'm not charging you anything over here. But remember, what I want is actually the excitement. Don't be a very casual learner. Then I would say better you leave. If you are just here to learn casually, that means you will be wasting your time, whatever you are spending over here. So if you really want to learn, be very high on energy. See, for me also, it's very well possible. Like I can be very low on energy and I can speak like this, the way you hear the lectures in the colleges and all those things. But what I want is basically, I want to give my 100% to you guys. So if I want to give the 100%, definitely I need some energy level at back from you guys, right? So be very high on energy because my performance depends on your energy. Okay. So let's now begin with the session for today. So let's have a quick recap of what we have seen. We dived into the tool chain where we understood what the tool chain is, then what are GCC and what all are its friends? What is cross tool chain? Why do we actually need the cross tool chain? How do we generate the cross tool chain? What are the various ways to get the cross tool chain? So those all things we saw. So that really would have given you a very nice picture about what the tool chain is. As I understand, there were many guys who were very new to this terminology of tool chain. Now, this would have given you the clear picture of what the tool chain is. Today, we are going to focus on another very important aspect, which is called makefile. Believe me or not, many of the developers are scared of touching the makefile. They don't understand the makefile. But once you understand the makefile, you can be very efficient in your work. Most of the developers, if you see like hardly 2 or 3% of the guys will be there who really know about the makefile. Most of the guys, they tend to ignore the makefile. But remember, knowing the makefile is very important. Not only that you want to become a build engineer, because of that you need to look into the makefile. Makefile can really make you really efficient. So that's why we are going to discuss about the makefile. We are going to write a makefile from the scratch, and this particular session is going to provide you all together different perspective for the makefile. I promise you that whatever you are going to learn, that you might not have seen learn the makefile like that ever, because what you would have seen is a very complicated makefile where people talk in a very complicated terminologies. Here I'm going to start from the scratch and I'm going to show you how does the makefile works. All right, so with that note, let's begin our day 9 with makefile. Okay, so first of all, we need to understand like why do we require the make? See, now what happens is makefile is a file which stores the instructions, okay, the rules. But the utility, the actual utility which you need is the make. Okay, so here we are going to speak about the make. Now, what is make? Make is something like a utility. And why do you need the make? Make is needed whenever you basically need to compile the several files. Let's say you want to deal with hundreds of files, thousands of files. You have a project which is big and you want to automate the build. So there we will be using the make. So I will be giving you a very simple example. So let's say we have the multiple source files, like we have main.c, we have hello.c, and we have functions.c. So what typically you will do in order to compile this particular thing, you will be basically using gcc main.c, hello.c, file.c, and then what you will be doing is you will be generating a output which would be like a hello. Now, over here, there are only three files. Okay, main.c, hello.c, functions.c. But imagine you are dealing with a project which has hundreds of files. You are dealing with something like a Linux kernel where there are thousands of files. Now, those kind of things will be very, very difficult to compile with the help of GCC. Of course, yeah, Naveen is saying use star.c. Yes, of course. But what if you have a several different folders over here? Okay, so let's say, so then you will have to point to that particular folder, because typically when you develop a project, you can't do something like every file you will be putting in the same folder. You will segregate it modular wise, right? So definitely this kind of GCC star.c is going to help you up to certain extent, but it won't help you any further. Okay, so nobody I have seen using GCC star.c or something like this. That actually doesn't work. So okay, so typically we tend to use the make file at every place. Okay, so now that's one part. Another thing is, like you see, like when I do, let me just share the screen over here. So okay, so let's say I have these three files, and let's say, as Naveen was suggesting, we will do GCC star.c. That means all the .c files, you compile it and you create the hello out of that. All right, so we did that. We got basically over here the hello. Now, one of the other problem with this particular approach is, let's say you have only changed factorial.c, or let's say I have just changed main.c. Okay, so I have just changed main.c, like what I have done is like uh, the factorial for 6 is something like this. Now what I did, I just changed one file over here. So when I basically use gcc star.c, it will again recompile each and every file. Okay, now let's say, imagine there are thousands of files. Now, compilation is a process which really takes the power, and basically it is the one which takes time. So if there are thousands of files, if I start compiling like this, I just changed one file, and just changing the one file, and I'm compiling all of those files, 19, like let's say there are thousands of files, I changed one file. So 999 files, I will have to again recompile it if I use this particular approach. So definitely I don't want this kind of stuff as such. So I want to compile only the file which has changed. So make can assist you in achieving that. Make basically tracks the timestamps. So it will just compile the file which has changed, and it won't recompile the files which have not been touched. So that's one of the biggest advantage of the make file. You will be able to do only the build for the compilation only for the files which have changed, not all the files. So there also this gcc star.c fails miserably. Okay, it fails miserably. So that's why, that's the another reason you will have to use the make file. Okay, now let's proceed and understand the need for make. So as I have already told, it is feasible to type this command for about three files. However, for the large projects having thousands of files and being scattered in the various folders, it might not be possible for us to type and navigate to each and every directory over there. So it would be inefficient to build it. Apart from this, you will be building all the files, though you would have modified only one. So make is the one which will take care of this particular stuff as well. It will only build the files which have changed. That's where the make can be very, very handy. And that's why, like you see, whatever projects you have, typically you use something like a make, CMake, auto tools, and all those things. The whole point of using that thing is to make the build process smoother. So if you are clear on this particular aspect of make, how useful the make can be for you, just drop clear in the chat box. Let me see how many guys are with me and what is the energy level in the room. Thanks very much, Varsha, Vikrant, Venkata. Not clear. Mustafa says not clear. Okay. Okay. So I will again repeat. Okay. Okay. So now what is the usage of make? So one of the guy told like he's still not clear what the make is doing. So one of the thing which make does is it will basically make sure that it will only compile the files which have changed. It won't recompile the files which have not changed. That is the advantage number one for make. Another thing, when you have thousands of files scattered in so many folders, typically when you create a project, you create the modules, and and for every module you might be creating a folder. And now if I want to compile all these files, I will have to type manually. I will have to type manually GCC, then you go to this folder, compile this, just go to this folder, compile this set of files and all those things and collect and do the stuff. So it would be very, very difficult to type all these things on the screen. Some of you guys might say, okay, I will write a script for that. Fine, you can write a script for that. Again, let's say you added one file, you will have to modify that particular script. Okay. So, okay, so device drivers right now, it's not relevant. So I won't be answering that, Chandra, over here. Okay, no. Okay, so Mustafa, so what is asking is, uh, Kishore is asking actually, makefile utility is for compiling the C code. Not really, actually. C++, you can use it for anything. And I will be discussing in a little while, like make is not actually just the compilation kind of stuff. See, compilation is being done by GCC. Anything which you want to automate, you can use the make over here. Okay. CMake versus make. Okay, so right now CMake is not relevant for us. Okay, so I will just focus on make. You can just check out on CMake. Okay, make is also a kind of a script. Yes, I agree. Make is also a kind of a script, but script you will have to write over there. Okay, and it is not mean for compilation. It is mean for execution. Okay, this make is meant for automating the things, and it is basically meant for especially for having the kind of like a regular expressions and something like this, which can make your build very, very efficient. And another thing, script won't be able to track what files have changed and what files have not changed. Make file is being designed in such a way that it will only compile the things which are changed. Okay. There is difference between CMake and make. Definitely. There is a difference in the sense the framework. It is the difference in terms of framework. Otherwise, purpose being served is same. Okay. So let's now move on. Now, what is make? Tool to automatically execute the commands. Like in this case, I can say it is like a script. Like when you write a script, you basically automatically execute the sequence of command. So tool to automatically execute the commands, we can call that as a make. Any number, any length. But now where does the make differs from the scripting is that it is based on the dependency chain. Like you create a dependency. The way you write the rules, the way you basically write this script, it is specifically meant for resolving all the dependencies, checking their timestamps, and rebuilding only the things which are required, selectively building the things which have changed and not touching anything else. Okay, so that's where it differs from the scripting. There is a dependency chain involved over here, which we are going to discuss in a little while. So it is typically based on the time, and majorly it replaces the manual process which you might be which you might be doing while typing on the screen. So if it effectively will save you the time because you will be only building the things which is required. So now what are the typical use cases, the usages of the make? So I showed you only one thing over here because we are very much familiar with the compilation, but make can be used beyond that. Okay, it can be used beyond that. So what all things you can use the make for? Another first thing, as we have discussed, project build system. Okay, project build system you can use the make for. Next, you can use it for packaging. Okay, packaging files like binary, documentation, and code. When you basically want to create the package out of that, you can use the make file over there. You can use the installation, like I can say make install. Now, many of you who have joined my other level of program, like we have the automated make file things. Like we type make install. What it does is it goes ahead and installs everything like a tool chain and everything kind of thing. So we have developed the make kind of automated thing where we just type make install and all the relevant libraries, everything will be installed over here. So that's another thing you can use make for. In a nutshell, anything that can be automated based on the dependencies, you can use the make. And we have been using this make very, very extensively, not only for building the tools, but for automating, not for building just the project. We have been using for everything that can be automated based on the dependency. Okay, based on basically, let's say this guy has this dependency, let pull this particular dependency and make this particular work. So we have used this extensively during our whatever the environment, wherever we basically want to be efficient. All right. So this is basically a make. Now, what we will be doing is we are we will discuss about this particular usage, like how does the make work, and rest of the things we will be directly switching to the practicals, where I'm going to show you everything with a practical. We will write a make file from the scratch, and I will explain you each and every aspect of the make file. Okay, and another, remember one thing, make is very, very exhaustive, but I'm going to give you a really, really good head start over here, which you can take it forward. See, remember, one of the things which we struggle with is to get started. And this particular thing, what I'm going to cover, you will be capable of reading any make file and writing a basic make file after the end of this particular session. Okay, so how do we use make? So typically, how do you use make is something like this. See, for instance, one of the simple use case, make hello. I'll just do make hello. So you remember yesterday what I was doing? I was doing GCC hello.c hyphen o hello. I was typing like this. Here what I will be doing is I'll just type make hello. And what it did is it has compiled the hello.c file and has given me hello over here. Okay, now let me again type it. Now you see over here, first time when I executed make hello, it generated hello from the hello.c. So now you see over here, one of the advantage of make, it compiled this particular program. And next time when you try to do make hello, it is showing it is up to date. There is no need to build. Now let's see what happens. What I will be doing is I'll just change this hello.c, change this hello.c. Uh, Let me just put one space in between. Okay, I have changed hello.c. Now let me do make. So you see it is recompiling. So it is the one which basically tracks the timestamps. Like if the dependency has changed, then only I will compile. Now, if I try to compile it again, it says it's up to date. That is one of the biggest advantage of make. It will only build the things which are required to be built. It won't build the things which have not changed ever since the binary was generated. So that's what is the biggest advantage, which can be which is a real time saver. Like you see, when I compile the kernel, it takes around 15 minutes to compile the kernel. Now, first time it will take 15 or 20 minutes. Now, the subsequent times, what happens is when I basically compile the kernel, whatever changes I would have made, it will just compile those. It won't recompile the whole kernel. So that's why the bigger project which you might be having, make could be a real time saver, that it will just selectively build the things which are required to be built. It won't build anything. This thing you can't achieve with the script. Okay, you can't achieve with the script this particular stuff. So that is what the advantage of Makefile is. Okay, now let's move on. So I have shown you how does the make works. Sorry, guys. So now it is being initiated by the command called make, and it is being controlled by configuration file. Configuration file. So what do I mean to say over here is, like, over here, if I want to basically make um, uh, uh, want to make work this particular make, you need to have some configuration file where the instructions should be there. Now you might be wondering, here I just typed make hello, how it worked automatically. Like, there is no configuration file, there are no instruction being placed. I just typed make hello. It was able to locate hello.c, and it is compiling this particular hello.c and giving me hello over here. So where is the configuration file? We don't have the configuration file over here, right? So if you see over here, I don't have any configuration file or something where I say you do this. So now here comes one of the important aspect. Make has some implicit rules. Okay, there are some implicit rules like this one, which we used, like this particular thing, cc hello.c hyphen ho hello. So this is the implicit rule. So even though the make file, make configure, the configuration file will be not there, it is going to work. Okay, but if you want to do something different, like let's say I say I just type make over here, then it says no target found. So here we gave the target as hello, hello.c was there. So implicit rule was applied. But when I typed make, it is cribbing. It is cribbing. No target is specified and no make file found. And this make file is what we call it as a configuration file, which contains the rules, which contains the rules. Rules means the instruction where you instruct the make utility. These are the things you need to follow. So typically the configuration file is named as make file. You will typically find it as a make file. Now, what happens is your configuration file can be named as GNU makefile, can be named as makefile, or it can be makefile. Okay, like with a small m. So these are the three things which can be automatically picked by the make utility. Okay, so what happens is GNU makefile. Okay, it is small over here. GNU makefile, and makefile. So let's say what happens is in your particular folder, you have GNU makefile, then you have a make with a make file with a capital M and make file with a small m. What will happen is the order will be, if there is a GNU makefile, that would be by default considered as a configuration file. That means the instructions will be read out from there. But if GNU makefile is not there, then next preference will be given to the makefile with with a small m, and the third preference will be given to capital M makefile. Okay, so remember, these file names are hard coded in the make system, that it always searches for these files. If any of these files are not present, it is going to crib. So in our case, that is what has happened. We don't have any of these configuration files. Neither we have a GNU make file, nor we have the make file with a small letter or make file with a capital letter. Okay, there is no difference between them. They all are configuration files. So makefile, GNU makefile, they are all configuration file. It is just the naming. Okay, the way you are comfortable with naming. So typically, most of the times you will see something like this, makefile. There will be one file with a name, makefile. Okay, everybody is clear till this point before we proceed? Okay, just drop clear in the chat box if you guys are clear. Okay, thank you very much. Thanks, thanks, thanks. So now let's proceed. Let's proceed with the practicals over there. Now let's say, if you basically want to have a configuration file which is not, you want to name the configuration file which is not one of these, then you can use -f. You can use -f over here. Okay, then it is assisted by many inbuilt rules. So I told you there is something called the built-in rules. There are something called the implicit rules which are already available. That's why make hello was working. Now we are going to move on to a typical rule. So I told you there is a configuration file, but what does the configuration file contain? What is the make file containing? It will typically contain the rule. Okay, so every make file which you will write, it will have something like a rule. So how does the rule looks like? Rule looks like a target, dependency, and action. Okay, so for instance, let's say I want to basically generate a file by name ABC, and the dependency for ABC is PQR. Given that dependency, how would you generate ABC? By using CP PQR ABC. Okay, so we have a target, dependency, action. This is how whole of the makefile operates. Okay, this is the building block of the makefile, a rule which has a target, dependency, action. Okay, target, dependency, and action is what we are going to have over here. So here I'm going to write a very simple makefile like this makefile in front of you. Okay, so let me just write over here the very simple makefile. Let's say I will call it as a sample makefile. So I'm creating a makefile with a custom name. Okay, I'm going to give it a custom name, and I will show you how do we run a makefile with a custom name over here. So I will start sample underscore makefile. I will write a file by name sample underscore makefile. And what I'm going to do over here is the same thing. What I have shown you, I'm going to put it over here. So ABC, then we have a dependency as PQR, and then you need to use the tab. Okay, we need to use the tab where I will put CP ABC CP PQR as ABC. Okay, copy PQR to ABC. So ABC, PQR is basically a dependency to generate the target ABC. Okay, so CP PQR, copy it as ABC. Now, let's run it. So for running it, what we will be doing, make -f sample makefile. Make -f sample makefile. Now, why I need to use F? Because it is not the standard name. It doesn't falls into any of these standard names. So we are going to use the custom makefile. We want to basically use the custom makefile. Now you see, when I try to compile, over here, when I try to run this makefile, it says there is no rule to make target PQR needed by ABC. So what it is struggling with is it is unable to find PQR. It is unable to find PQR. So since it is not able to find PQR, it is not able to generate ABC because the dependency itself is not there. In our rule, what we have done is for generating ABC, PQR is a dependency. Okay, but the thing is, we don't have the PQR over here. So that's why it is saying no rule to make target PQR. Now what I will be doing is, I will make over here touch PQR. I will create a file by name PQR. Okay. And let's see what happens now. When I do this, it goes through because it was able to locate a file by name PQR. Since it was able to locate the file by name PQR, it has done the copy of that. Now, when I execute the same thing again, it says ABC is up to date. There is no need to copy. Okay, this thing you can't do with scripting. Okay, where you are tracking of the various things over here, where you are tracking the timestamps and all those kind of stuff. So it says ABC is up to date. But if I again delete PQR, now ABC is up to date, but PQR is gone. So that's why it is scribbling again. So rather than me doing the PQR, me creating that PQR with a touch, what I will be doing is I will add one more rule over here. Okay, so you see here I was doing manually, but that's a headache, right? Like why I need to do touch? Can't the make file do it for me? So I will modify the make file over here. I will modify the make file over here, and I'm going to add one more rule, PQR and touch PQR. So now what will happen is, see, if PQR is not there, it will try to search for any rule with the help of which you can generate PQR. Okay, so you see here, over here, PQR was the dependency. Here, PQR is a target. So what it is going to do is, it is going to basically generate, it now has the rule how I can generate the PQR. So let's see what happens now. Okay, let's see what happens now. So I will be again running this particular thing. Now you see what happens. It didn't find PQR. So it had that rule. So it generated PQR. And then it copied PQR as ABC. So this is what I mean by dependency chain. So likewise, you can have a thousands of dependency chains over here, where one thing is dependent on other, one thing, other thing, second thing is dependent on the other thing. Then one of the thing is dependent on 3, 4 more things. So this is what actually your make file can do over here. Okay, this is what your make file can do. Now when I run it, it's up to date. Okay, now let's say I delete ABC. Okay, now I just delete ABC, and now it just does CP. It is not doing touch PQR. That's the biggest advantage. Okay, thanks very much, Mustafa. You are absolutely clear with that. That's great. Okay, now this is how Makefile works. If you understand the crux of Makefile like this, you will never forget about this particular stuff. And this is how I learned about the Makefile, and this made my life very simple. Typically, when you learn about the Makefile, people will start with a compilation, people will start with the jargon terms. I don't want to start with the jargon terms. I want to explain you the things in a very, very simple manner so that you should never, never forget about this particular stuff. Okay, so now we will proceed. We will proceed. All right. So let me just understand from other guys also, like, are you guys clear with how does the make file work? This is the crux of the make file. Okay, fantastic. Thank you very much, Ankit. Thank you very much, Lavanya. Others also, if you guys are with me, okay, okay. Thank you, Chaitanya. Thank you, Disha. Now I see the energy level in the room is really, really back. Fantastic, Jay. Thank you very much. Now let's proceed. We'll be proceeding with a make file. Now, yeah, so this one kind of thing we basically saw. Now here there are 3 levels of dependency. You see, uh, XYZ is dependent on ABC. ABC is dependent on the PQR. PQR, you need to create it over here. So it will go as a dependency chain. So if ABC is not there, this rule will be applied and ABC will be created. If PQR is not there, then this rule will be applied and the PQR will be cleared as such. Okay. Okay. All right. So now proceed. Now let's proceed over here. Now what we are going to do is we are going to create a make file for automatically compiling a C code. Okay, a C program which we are going to compile. Again, the same rules. No hi-fi stuff over here. Okay, let's do. Okay, Tanga is asking if we moved the touch command, we can get up to date in first attempt itself. Yeah, yes, of course. If you are not doing a touch, then it's a first attempt itself. It would be like, no, it won't. You won't get the up to date because target won't be there. The target has to be there. Target ABC will be there. So Tanga is asking if we moved the touch command, then we can get up to date in first attempt itself. No, because ABC won't be there. So if ABC is not there, then copy has to be done. Okay. So now let's move on. Let's move on. We are going to compile hello.c. Whatever this hello.c was there, which was working with an inbuilt rule. Now we will write a very simple makefile for that particular stuff. So let me create over here some makefile. And what I will be doing is a very simple stuff. Hello is the target and hello.c is a dependency. And for compiling this particular, for generating hello, I need to do gcc hello.c hyphen o hello. Okay, gcc hello.c hyphen o hello. So target, dependency, and the action. Now let's basically run this stuff. Now I will just type make over here. So it says hello is up to date. I will just do rm minus f of hello. And let me do make over here. So you see gcc hello.c hyphen o hello. Okay, so this is basically generating the hello for us. A very, very simple make file for us, which is compiling a C code over here. Okay. Earlier, if you see when the make file was not there, for example, when let's say I move the make file to make file one, and if I type make, what do I get? No target specifies and no make file found. But if I basically move this back to make file, because this is the standard name. Okay, for multiple targets, Karthik, we will be coming. We'll be discussing that in a short while. Let's not jump. Let's understand it from the very basic purpose, and I will explain you all those things. Okay, so I will just do make, and now it is showing it's up to date. And now what I want to do is I basically want to try out the various stuff. Now I have generated I have basically created the make file. Let's say I want to clean it up. I'm generating the hello. I want to clean it up. So what I will be doing is in this make file, I would include another rule, another target called clean, where there is no dependency. And I want to basically use rm minus f hello. So whatever is the output, typically in the make file, you will typically find clean. Like let's say I want to clean up, like whatever compilation or whatever build has gone through, I just want to clean up all those things. Then you can use clean as a target. So remember, there are two targets over here, hello and clean. Okay, so now we will come over here and I will do make clean, make clean. What it is doing, removing the hello. And now I can do make, it is compiling it. Okay, so that's how the things are working. Of course, Hari Krishna, like .o and all those things, whatever you want to include, it is just a matter of taking the action over there. Okay, clean will remove the file. Exactly, clean is going to remove the file. That's what typically the cleanup does. Okay, why not make hello? See, if the make file is there, the default target will be already picked up. So typically, let's say you see over here, when I used make file, the first target is hello. So by default, whatever is the first target will get executed. Okay. So now clean was a second target. So it doesn't get executed automatically. You will have to give it specifically. Over here also, I can very well do make hello. That's a valid thing. But since my first target was already there as a hello, so I don't want to use this particular hello specifically over here. But this will do the same thing. See, I can use make hello. So the question was, why not make hello? Why am I doing only make? The reason is the same, because hello is the first target, so it will automatically pick that up. That's the reason. No, not all the targets. Okay. So here there is a very interesting question from Elsa. What he's asking is, like, all all the targets executed automatically? No, only the first target. Only the first target gets executed automatically. Rest of the targets, either you will have to specifically mention them, or you need to create the dependency chain. If there is no dependency chain, this won't get executed. So you saw over here, when I typed make, only this got executed. This didn't get executed. Okay. So yes, if we rearrange, the clean will be the first. Clean will be the first. You are right. So if I put clean over here, clean, if I put above hello, the clean will get executed. And the hello won't get executed. Okay. So this is how I can add another target over here. Now, what we will be doing is, now see, this kind of stuff looks very, I can say, uh, like without any variables and everything, like a, a plain commands. Rather than that, what I would like to do is I would like to use the variables over here. Okay. So now what I will be doing is cc equal to gcc. Then I need to use some flags. Okay. So to the compiler, I want to give some flags. So C flags equal to hyphen wall. Give me out all the warnings, possible warnings. Okay, don't ignore the warnings. Show me on the screen all the warnings. You show me on the screen, whatever are there. And then what I would like to do is RM. I would like to, rather than putting RM minus F, I will basically use over here the variable as RM. So these are the make file variables. You can define your own variables over here. So what I will be doing over here is, I will be using CC over here, RM over here, and C flags over here. Okay. So you see, now it looks better. Actually, if I want to change, if the GCC is used at various places, CC is used at various places, or let's say tomorrow I want to modify this file to do the cross compilation instead of a native compilation, I can just change CC over here. So this looks a lot more, I can say, decent compared to what it was. Okay, you can use any variable, not necessarily CC, but why I use CC? Compiler, for compiler, cross compiler or something like that. Okay, so you can use anything, Chaitanya. There is no, it's not mandatory. It's just a variable. But typically, you will find everywhere, like as a de facto standard for every compiler, we use the CC. Okay, so now you see this looks a bit neater, and it will be doing the same task. Clean, compile. So it's working fine, but now it looks a kind of pretty organized. Okay, so this is how the things are working for the make file. Now let's see how do we enhance that. Okay, now someone was asking, how do I support the multiple targets? Okay, if I basically want to have the multiple targets in place, how do I support it? Now, what we will be doing is over here in the same make file. Let me see. Yeah, this is the one, multiple targets. Now, what I have is, I have a hello.c, I have a main.c over here. we have the hello.c, and then we have this main.c, and I'm going to copy this make file over here. And in this make file, what I'm going to do is similar to hello.c, I'm going to include main. Okay, main. So this is what I'm doing over here. So I have now three targets as such. One is hello, another one is main, and then there is a third one which is clean. And in the clean, what I will be doing is I would be now cleaning up main as L. Okay. Okay, Karthik, that's so Karthik is asking like, how did I replace it so fast? So it's a magic of VI. We'll learn about this in the day after tomorrow's session. Day after tomorrow, I will be sharing across the tips and tricks for using the VI, which makes me really, really efficient with a VI. Okay, so day after tomorrow, just I will be sharing all the I can say secrets of this particular VI. There is no extension for makefile. Okay, Krishna, there is no extension for makefile. So now you see, uh, this is how you have the multiple targets now. So as usual, what is going to happen is when I type make, it's just going to compile hello. Okay, it's not going to compile main over here. No compilation of main. Okay, only hello. If I want to compile main, what I need to do? Make main. Make main. So now it is compiling that main. So you see C flags have been expanded and all. Okay, someone is asking what is C flag? See, for the compilation, you have to give the sometimes the flags, like you want to compile it with the debug symbols. You need to compile sometimes with some optimization levels. So all those things are the flags actually. Flags means the options to the GCC. Those are basically the C flags. So now you see what has happened is like I need to give the name of that particular target like in order to compile main because it doesn't automatically falls through. Okay, it doesn't, it won't really fall through over here. Like only the first target will be executed, next target, unless it has the dependency. Unless it is a dependency, it won't be executed. Okay, so let's say over here for hello, if I make main as a dependency, if I make main as a dependency, then it will switch over here. But since main is not a dependency for us, it's not going to switch. Okay, so I will show you. I'll show you. So for example, let me put it main over here. Okay, but you see, ideally main is not dependency for hello.c, but I'm just putting it. Okay, so let's see. So what I will be doing, make, clean. And now if I do make, you see over here, main got compiled because main was a dependency. So unless you have the dependency, it won't extend. Oh, okay, it won't jump to that particular thing. So again, since that's not a correct thing to do because for hello, the main is not a dependency. So I'll just remove it over here. Okay, and we'll keep it like this for time being. So this makefile, we are going to extend it further. Okay, we are going to enhance it further over here. So what we will be doing is now I want to compile everything like we have been asking, right? I want to compile hello also and make also. What should I do in that case? Then yes, n number of dependencies are possible. You can, Chandan, you can have as many dependencies as you want. There is no limit. Now what we'll be doing is, let's say all the time when I type make, yes, right, Rajdeep, what you will be using is you will put the first target as all, then you will put hello and main. So the first target is all. Okay. So now you will put hello and main over here. And now what is going to happen is when I type make, both will get executed because the first target is all. Okay. First target is all. That's the reason that's how you can have all your dependencies being included over here. All right. So hope you guys are getting a clear picture of how the make file works. Just drop clear in the chat box and let me see how is the energy level in the room. Okay, thank you very much, Shahid. Only response from Shahid. How about others? Okay, okay. Everyone is responding. Thank you very much. Thank you very much, Mas. Thank you very much, Neeraj. Fantastic, fantastic. So that's the energy level which I really, really want to see. Thank you very much, Pragnesh. Uh, thanks, Mustafa. Okay, so let's now proceed with this particular stuff. Okay, so do we need hello.c and main.c in dependency? Definitely we need it. Okay, definitely we need this. From the different folders, you just put the different paths. So the question is like, how do I get it from the different folders? So basically you get into the different folders, you give the folder path. Okay, all right. Now let's proceed. Now what we are going to do is, now I'm going to show you one stuff over here. For instance, if you see, for instance, what I'm going to do is, I'm going to create one file by name clean. Okay, I have created one file by name clean. Now, when I type make clean, it says clean is up to date. That's a problem, right? It is now, when I type make clean, it is searching for the file by name clean, and it is not executing the target because clean doesn't have any dependency, right? So there are no dependency, and there is already a file existing with a name clean. So it says it's up to date. You don't need to change over here. You don't need to do anything. That means we are not able to execute the clean now. I can do make, but make clean is not working. So now here we have a problem. That means our target is being identified with the file name. Now, if there exists a file name with this name clean, it's not going to work. But we understand that clean is not dependent on any file. We want to execute clean irrespective of whether the file is present or not. So here comes one of the enhancement to the make file which you need to do. Okay, and what you will be doing over here is we will be having something called phoning. Phoning. Okay, phony clean. Now what we are saying over here, it has no dependency on this particular file or something like this. The moment you add dot phony and clean, what is going to happen is when I type make clean, even though the file is there with a name clean, that will be ignored. It won't look for any file in the file system. It will just go ahead and execute that particular thing. Okay. No, it screen is not hanged, Chandan. It is working. I hope everybody is able to see the screen. Everybody is able to see the screen. Okay, okay. So Chandan, it's an issue at your end. Please try rejoining. Okay, because the screen is not hang, I can see. Okay, so you see, it is lagging a bit. Okay, it's lagging a bit. Okay, let me see. Let me just check if there is any issue at my end. What is the speed I'm getting? Okay, so I see. No, it's all good at my end. I don't see any issue. Okay. Okay, everything is fine. Thank you very much. So you need to check at your end as such. There are no issues at my end. Okay, all right. So you see now this is how the phony target one. So phony targets are the one which you don't want to make it dependent on the files. Okay, you don't, irrespective of the file being present or not, this phony target should always work. So that's how this particular thing works. All right. So let's now extend this make file further. Now what I want to use is over here, we call something called automatic variables. Okay, now let us actually get into the automatic variables over here. Now, what are these automatic variables? So automatic variables are the variables which are automatically defined by the makefile, and they can be very, very handy. For instance, rather than me typing over here the uh, hello.c over here as well as here, and hello over here as well as here, what I can do is I can use some of the automatic variables over here. So what I can do is this particular file. So I'll keep these two things. I'll just make a copy paste of this so that this change should be visible to everyone. So I've commented this out, and what I'm going to do over here is I will be using this is the automatic variable for the dependency. For the dependency, dollar less than. Dollar less than basically is the dependency. So over here, it will be replaced with hello.c. So rather than me typing hello.c again, this will be automatically taken care over here. And here, we will be using dollar at the rate. Okay. So now you see, you don't have to repeat this particular stuff. Target, dependency. So this will be, sorry, this is dependency, this is target, dollar at the rate. Okay, now, okay, here also I will do the same thing. I will use dollar less than and dollar at the rate. Okay. Now, yes, if there are multiple dependencies, then you will use, that's a good question. So Rajdeep was suggesting something called dollar character. So if there are multiple dependencies, what will happen? Then instead of dollar less than, you will use dollar caret. Okay, dollar caret. But we will be using dollar less than over here. Okay. So now we have got this particular stuff, and I would now try to run this same stuff. Dollar at the rate is target. Okay, dollar at the rate is a target. Target is hello. Over here, target is main. Okay. So now let us do make clean. So you see, it works in the same manner, but now your make file looks a lot more neater. Okay. Wall is enable all the warnings. Okay, enable all the warnings. Show me all the warnings which might come. So right now, target, there is no need to give the extension. Targets are extensionless. Hello, main, and all. You define the targets. Okay, so now you see over here, this is how the things work. And now it looks, this is the make file which you would have typically seen. Okay, but we will improvise it further. Okay, we are going to improvise it even further. What we are going to do is, we are going to do something like a pattern matching over here. Okay, we will use the pattern matching. For instance, you see this rule and this rule, they look very similar, right? They are looking very similar. So why should I basically repeat it? So what I will be doing is I will be using a pattern over here. Okay, we will be using a pattern. Okay, so Naveen, if you want to use any extension, no problem, use exe, no worries. Okay, instead of hello, you can use hello.exe, main.exe. There is no restriction on that. Okay, you can use exe. Okay, but since in Linux we don't use any extension, I'm not using that stuff. But you can name target whatever you want. Okay, so now what we can do is I want to basically unify these two things. Like this is a repetition, like same thing we are doing twice. So what I'm going to do is, let me just comment this out. And I will be instead creating a single rule where I will specify percentage.c. Okay, hello.c was my dependency. And then what we will be doing is something like this. So what it says is this is like a pattern matching. So target, if it comes as hello, so this will be given hello, and this will be hello.c, and this will take the target dependency and the target over here. Now you don't need to write two different rules for hello.c and main.c. You don't require two rules. Only one rule will take care of it with the help of pattern matching. Okay, so now let's see what happens. You see, only single rule, and you are able to make the things work. Okay, so you see, now your make file looks very, very short. Okay, so this pattern matching is an amazing thing which is available in the Makefile. So now I hope you are able to understand these things. We can't do it with a scripting. Okay, scripting doesn't allows you to do all those kind of stuff. That's why Makefile is way too different from your scripting. Percentage means when you type hello over here, the target will be hello. So it will try to have hello over here, and hello will be given over here. It will be hello.c. Okay, so it will take it from the target over here. So you see now your make file looks very, very short over here. Okay, so with this particular pattern matching, you can actually write a very, very compact kind of make file. Okay, this is a pattern matching, Elsa. So basically whatever comes as a target, percentage, it will take hello first, it will come, it will take here, then main, it will come, it will take there, and it will do the replacement over here. Okay. Yes, exactly, exactly. Now this makefile learning will be really, really helpful. Now when you read the makefile, you will have some level of comfort. I would say makefile is an ocean. If you really, really work on this, it will really, really make your work very efficient. Okay, you should use it. Developers tend to ignore Makefile, and that's the biggest mistake developers do. Okay, Makefile can automate your testing. Makefile can automate lots of your tasks. It is one of the very, very useful tool for automating. If you are ignoring it, you are losing a major part of automation. Okay, so that's why try using it, the Makefile and the scripting. These are the very, very powerful tool which developers ignore. We as a developer think like writing a good C program or writing a good C++ program is more than enough for me. That is not the case. Guys, if you want to basically grow faster, then automated tools are very, very important. Very, very important. Okay, so yes, now the question is coming, how about having a multiple .c and the H file? So I'm going to come to that point as well. Okay, that is what is the next level of thing where I would like to show you. Okay, default goal we'll discuss now, and then single executable from multiple dependencies rather than multiple targets. It will be multiple dependency. All right. And now since we are into the day 9, and if you are really, really enjoying this session, so may I ask for a favor for a couple of minutes, if you can provide the Google review, like how sessions, so that it can reach to more audience. Okay, so 21-day session typically will keep on happening as such, and more such things will be happening in this particular thing. Okay, so here is the Google review, and the guys who are new and want to basically subscribe to my YouTube channel, where basically I keep on putting interesting stuff, and on the LinkedIn also you could follow me on this particular stuff. Okay, so just take 2 minutes of your time before we proceed and provide your useful things over here. Okay. Okay. Embedded Linux session. Typically, I don't know. Embedded Linux 21 days session. I'm not sure when it will be started. Okay. So just take 2 minutes of your time, guys, and we will continue with this particular stuff. Provide your Google reviews. So what I want is provide some key takeaways. What did you really learn from this session? How did you find it useful? So like, give me a paragraph type of review rather than just typing good, excellent, or something like this. That's not going to help anyone. So those are like uh, reviews which are being bought. Okay, reviews which are being purchased. But I want to get the genuine reviews from all of you guys. So typical, whatever reviews you are seeing on my Google, they are the genuine reviews. Okay. I don't want to purchase the reviews or something like that. So I want the reviews from the guys who have really enjoyed. And just remember, guys, like if you are really learning and if you want others also to learn and if you really appreciate, so at least a little bit of appreciation you can provide me, which can act as a booster for me. Okay, Google review link. Let me share it across again. A Google review link for everyone. Okay, so here is the Google review link. Okay, so guys, please provide your Google reviews over here. Okay, so I didn't share the Google review with everyone. So here is the Google review link. Let's take couple of minutes of your time. So if you really find it useful, then I would really be happy to read your reviews. Okay, so that will act as a booster for me. Okay, so just take a couple of minutes of your time. We are going to resume in just 2 minutes. Okay, so give me some paragraph type of reviews rather than just giving good, excellent, or something like this. That won't help anyone. Just type like your key takeaways from these sessions. Shayad Beaglebone related stuff typically see, I have a paid program, 21 days challenge. It might not be possible to have a 21 days kind of challenge as a free session over here because nobody will buy Beaglebone. Okay, so that's why I've conducted all these sessions where you will have to make zero investment. Okay, so it might not be possible. Yes, paid one. Shahid, you are already a part of a paid one. I'm not sure actually. It's a paid 21 days challenge. Okay, you wanted to join that. Okay, sure. We'll talk of that later. Okay, so there is a 21 days challenge program for the Linux device drivers on BeagleBone Black. Okay, so there are several guys who are part of that. In few, I can say days, I might conduct a webinar on that to provide you the details. So typically, I don't offer my courses or modules without providing you the clarity. So that's why I first conduct the free webinars, and then only I basically ask you to join that, because I don't want to want the guys who are not clear with what they are getting into and buy those courses just because of the hype or something like that. I want you to be very, very clear on what you are getting into. Yes, BBB Linux drivers, it's a 21 days challenge, which is a paid program. Okay, so now we will resume. Okay, so thank you very much, whoever has provided the reviews. I don't want to hold you longer. Thank you very much, guys. Uh, and hope each one of you has provided me the reviews. Now let's move on. Now, sometimes we want to include a default goal. For example, till now what we saw is all is a default goal. Okay, why it is a default goal? Because the thing is that all is coming first. So in a sequence, all is the target which is coming first over here. So that's why it is getting executed. But what if all is not my default target? My default target is like when I type make, I just want to execute main. I want to just want to execute the main over here. So I want my default target as main. So here what you can do is there can be something like a default. So in this case, what will happen is, see, the biggest advantage is it was very difficult for us to maintain the order. Okay, let me keep this as first, let me keep this as second, and something like this. So always I need to make sure that all is always remaining at top, which is difficult and might not be always possible for me to do so. So instead, what you can specify is that my default target is default goal is my default goal is main. Okay, main. Now see what will happen is over here, even though all comes first, but only main will be executed. Okay, only main target is going to get executed over here. Let's see. You see, only main. Now, if I want to execute all, then I need to type make all. Okay, so if I do make clean, you see what is happening? It is, you have to specifically tell you need to execute target all. Otherwise, your default target is just main. So this is one of the important stuff which will make sure that you don't need to depend on the order. Whatever may be the order, whatever is the default goal is the one which will get executed. So in this way, you can put them in any order. Okay, I can put default goal as all, and all can be anywhere. So no need to have that level of ordering. So that you can write the make file freely. Okay, so if you guys are clear with this particular stuff, just drop clear in the chat box. Let me see if you guys are with me. Okay, thanks very much, Mars. Thank you, Ankit. Thank you, Varsha. Thanks for maintaining that energy level. Now, okay, Kishore is saying he's not clear. Okay, so let me explain you again. See, by default, what happens is you have to maintain the order. You have to maintain the order that when I put whatever target I want to execute by default, that has to be placed first. That has to be placed first over here. Like whatever target I want to get executed by default, that has to be placed first. But what if I place all over here? Okay, if I put all over here, then it will directly come over here, and that would be a problem. Okay, because this is just the implicit rule. So how it is going to work? It will need some target. So instead, what I can put is my default goal is all. Okay. Now you don't need to necessarily put all at the beginning. It will automatically be taken care. So now see, you see, all got executed even though it was placed towards the end. Earlier, all you have to place always at the top. Now there is no need. Okay. So whatever default you want to have. So when you just type make over here, okay, when you just type make over here, the default goal is all and it will get executed. So that's the advantage of default goal. Hope everybody is clear now. Okay. All right. Now let's move on to the final thing, which everybody has been asking, how to generate single executable from the multiple source files. Okay, so here again, see, there is one thing like where you can actually extend it, like where you can use the wild characters over here. So we are not going to get into the wild characters right now, but I'm going to just show you the simple stuff over here. So if I have the multiple files, let's say I have this source, and in this source, what I have is I have main.c, hello.c, and factorial.c. So how it looks like is in the main.c, we are invoking print hello and we are invoking factorial. So hello, print hello is defined in hello.c and factorial is defined in factorial.c. So in order to generate this particular thing, like in order to generate the target, like now I can't just do something like this. I can't just compile gcc main.c. If I do this, what I will be getting, I'm going to get undefined reference to print hello, undefined reference to factorial, because these are not defined. I need to link them together. Over here, I need to link them together. So for that, what I will be doing is I will be writing a make file. And right now I will be writing it very simple make file rather than using, okay, let me just take it from the earlier one itself. CP, multiple targets, make file. Let me copy it here. And what I need to do over here is, over here, it's not going to now work like this particular stuff, like percentage and percentage dot C. This particular rule is not going to work over here. Rather than that, what we will have to do is star.c, and now my target will be just hello over here. So I just need to make, I just want to compile one file. Let me put it main. Over here, I'll just put main, and okay, default goal, let me put it main over here. Okay, so it will come here and star.c. And here, instead of using dollar less than, I will be using dollar caret. Okay, dollar caret. And in this, I need to kill your main. There is no hello. Okay, so remember, this is a simple make file. Still, it can be expanded using more wild characters, and we can make it even more proper. I'll just show you that particular make file rather than me writing that make file. I will show you how does that make file looks like. Okay, so I will do this particular stuff, and now you see GCC factorial.c, hello.c, main.c, and it We got the main. And now I can execute this. Okay, so this simple thing, typically you write it using the wild characters, which are more efficient. So I will just show you that makefile, okay, rather than spending time on writing that particular stuff. Yeah, so see, this is how it looks like. Okay, so yeah, so Rajdeep, your question also will be answered here. If changed anything in factorial.h, will it work? So if for that to work, include deps. Function.h should be included as a dependency. So then it will be done. So now you see, how does this makefile looks like? So what we are doing is, we are first collecting all the sources. So we are doing wild character star.c. So all star.c, you put it in the sources. Then object files, all the object files, what you do is, whatever is the .c, you get .o for that. So hello.c, factor for hello.c, you will get factorial.o. For main.c, you will get main.o. For uh, factorial.c, you will get factorial.o. So objs will contain all the list of .o files. So in a nutshell, if I would like to tell you how it will be looking is, sources will be assigned something like this. Sources will be equal to main.c, factorial.c, and there will be hello.c. This is what would be there in the sources. Now, in the objs, it will be assigned main.o, factorial.o, and hello.o. So these two variables we have defined. Main.c, factorial.c, hello.c. Objs main.o, factorial.o, hello.o. Okay, what is mean by wildcard? See, wildcard is like a matching, in the sense like when you use a star, you match with all the .c files. That is wild characters. Okay, wild characters, which basically can do some matching rules and regular expressions typically. Those are the things. Now see what happens. What we are doing over here is, the target is %.o. From there, the dependency for this, the dependency is %.c. And how do you generate %.o from %.c? That means from hello.c, I want to generate hello.o. So what I will be doing, -c, then the whatever the dependency, and then I will get the target. So typically it will start like this. See, first you are going to go to this target hello. You will provide the dependency as objs. Objs are .o. It will come over here like hello.o. From the hello.c, you will get hello.o. Similarly, for the main.o, you will use main.c and generate the main.o. So all these things will happen over here, and it will give you the final target as hello. Okay, so this is how typically you will find the makefile is written. Okay, so how about .a files? Okay, Mustafa says not clear. Okay, so let me tell you what does, so as you understand, this is all .c files, this is all .o files, and what happens is my target is hello. Hello is dependent on objs, which are .o files. Now, when the make runs, it will try to find out .o, but .o won't be present. So what it is going to do? It is going to go jump to this rule. So if I want to generate main.o, the dependency is main.c. And then from main.c, how do I generate main.o? By using gcc -c main.c -o main.o. Okay, so likewise for main.o, this will be executed. Hello.o, this will be executed. Factorial.o, this will be executed. And finally, you will have all your dependencies, and using those dependencies, that means all your .o files over here, you will generate your target. Yes, compilation of C files will take the .h files. That's true. Okay, is it clear now? Why again taking .h? No, again taking .h because the reason I'm taking a depths over here, let's say you change something in functions.h. That will not that will not regenerate again main.o. See, functions.s is included in main.c, but for the make file, it is not known that functions.h has changed. So if you want to make sure that even if the functions.h is changed, then this is the dependency, then you need to mark it as over here. Okay. Yes, wildcard for .h we can generate, but there is more better way available where you can extract the .h files. Okay, if you want to use .a meet, then basically have a rule which will generate .a files. Okay, so use the archive utility and you will be able to generate the .a files. Okay, all right. So the difference between dollar less than and dollar caret is dollar less than will only take a first dependency. Dollar caret will take all the dependency. Okay, so now someone is asking what is the difference? Like earlier we are using star.c and here we are using wildcard star.c. What is the difference between that particular thing? Okay, so this was basically the way where we are assigning it to the variable. If you want to assign it to the variable, you need to execute the command wildcard. If you want to use it as a library, generate the library .a. Have a rule where you will have something called archive. Okay, where you will have something like a %.a and have the rule for that. And over here, we will put the rule for archive. Instead of objs, put the archive over here. So that's how it will be doing. It will be done. Okay, or if it is a SO, you can generate the SO file from there. All right. So yes, this is what we have for today. And I tried to simplify it, this particular stuff, as much as possible for you guys, and hope it has given you a good amount of clarity. Now, if you want to learn the make, there is a very nice tutorial available. You just type make tutorial on make. There is exhaustive actually a document available for that particular thing, so you can follow that particular stuff. So what I have shared over here is like a uh, stuff which can help you get started, so that when you read the make file, you should not get confused. This is how it operates. And now there are many advanced things in a make file. It's an ocean, actually speaking. Okay, make file is an ocean. So what I have explained you is just the tip of the iceberg. There are many things which are yet to be uncovered in this particular stuff. But head start is the more important. And then whoever is interested, definitely you will be able to deep dive and proceed further. Okay, so hope you guys have enjoyed this particular session. So let me just recap. What did we learn? Make and its need. Okay, thank you very much, Ankit. So make and its need, make file and the rules, writing the make file, compiling with make file. Tomorrow is going to be another exciting session where we will dive into the JIT, a very important thing, the version control system. We will again start from the basic, and we will be covering the aspects like cloning the project with a JIT, committing the changes with a JIT, creating the patches. So all those things will be covered tomorrow. All right. So with that note, we will conclude the session over here. Thank you very much, guys. And thanks for your compliment. Thanks for your Google reviews. We will meet up again tomorrow for another exciting session. I really love the excitement which is there in the room. I don't need thousands of people in room. Even a single or two guys will be there with a super excitement. Even that is a big booster for me. Okay, so thank you very much, guys, for staying with me till 9 p.m. over here. So with this, I will take a leave and let's meet up tomorrow for another session. Okay, thank you very much, guys, and take care. See you tomorrow. Bye bye.